Good morning. All right, it's bright and early. It's actually a Sunday morning at the ungodly hour of 6:50 a.m. All right, quiet time in the Thornton household. All right, so what we're doing today, we're doing the quotient rule. All right, 2 more lessons and we're done for the year. Isn't that crazy? All right, so we did the power rule and the product rule last week. This week we're doing the quotient rule. Now the quotient rule obviously involves some division. So if you were talking about, say, f of x divided by g of x, we would use this one rule. And the rule is, all right, I'm going to write it out. I'm going to keep out the x's to keep it simple. But it kind of goes like the product rule. And the quotient rule goes, the derivative of the first times the second minus the derivative of the second times the first all over the second squared. I know that's weird, right? All right, well, there is another way to remember it, and I think if you have friends in Miss Zumas's class, they'd get it this way. Think of the top function, f of x, as high. Think of g of x as low. So you're going to hear this next year as well. It just doesn't roll off my tongue as well as it does, other teachers. All right, so it goes like this. Ready? I'm hoping I'm in there. It goes low d high minus high d low all over low low. So low d high minus high d low over low low. That's exactly the same thing here. Look, it's the low guy, right, times the derivative of the high minus the high times the derivative of the low over low low. All right, it's up to you. Low d high minus high d low over low low, or the derivative of the first times the second minus the derivative of the second times the first all over the second squared. I like the one in the box. That's just the way I was taught it. But your call, okay? It's whatever you're comfortable with. All right, so quotient rule. First guy here, example 1. All right, we've got this 2x cubed minus 3x squared plus 2 divided by x squared. You look, you say, oh, look, I got a quotient. I got to use the quotient rule to find the derivative. All right, what I can tell you is that the algebra here is probably going to give you the most trouble over the actual quotient rule, okay, because it's all about the simplifying. Now, I really, really hope you wrote this down or you printed this sheet out. This is something that you will refer back to right in the beginning of next year. So, again, no fire pit material. All right, so we have our example here, example 1A. All right, so let me just make sure we're all in here. All right. The derivative of the first. So the derivative of the first is going to be 6x squared minus 6x. Okay, that's the derivative of the first times the second minus the derivative of the second, 2x, times the first. Oh, shoot, there's a 2 in there. 2x cubed minus 3x squared plus 2 all over your low one squared. So x squared times x squared. All right, so you've used the quotient rule. Now this is where it gets good. This is where you have to start simplifying. So back to old school algebra. All right, so when I simplify this, I'm going to get 6x to the 4th. All right, and then minus 6x cubed. All right, so now I'm distributing this negative 2x. All right, negative 4x. Oh, shoot. Yeah, negative 4x to the 4th. Plus 6x cubed. Looks like minus 4x. And like I said, this is where it gets like crazy. All over x to the 4th. Okay, let's see what we can simplify here. All right, 6x to the cubes cancel out. 6x to the fourth and negative 4x to the fourth. That's going to give you 2x to the fourth. Minus 4x all over x to the fourth. All right, so let's see what we can do here. At this step here, I think we can pull out a 2. We can take out an x. So if I take out 2x, it's going to leave me with x to the third minus 2 all over x to the fourth. Okay, so this x will cancel out one of these and make it the third. So I think the best we're going to get here is, let's see, 2. I'm going to write it over here. Can you see that? Yep. 2 times x cubed minus 2 all over x cubed. And that's as good as it gets. So quotient rule in purple, everything else is algebra. So it gets a little tricky. And as we get further down, like when we get to D, I'll write out the derivative, I'll write out the final answer, and then I want you to figure out the steps in between. I'll, of course, attach a picture of it on the side, but it takes way more than what I allotted space-wise. Like, I'm mad at myself, but it is what it is. So let's move this over. Let's take a look at letter B. Again, quotient rule, I don't think it's as hard, but you know what? Let's see what happens. All right, so the derivative of the first, 2x minus 2, right, using the power rule, times the second, ew, now we're going to have a binomial, minus the derivative of the second, which is 1, that's nice, times the first, all over the bottom one squared. Okay, so if I multiply this out, let's see, I'm going to get a 2x squared. Let me switch my colors. 2x squared. All right, so check this one out. You're going to get, let's see, plus 4x. I guess I'll take my time here. Minus 2x minus 4, and then minus x squared plus 2x. I'm just going to leave the bottom one for now because I just want to see what happens. We can always go back and fix that. Let's see what we have here. All right, 2x squared minus an x squared. That's going to leave me with x squared. I got a 4x minus 2x, right? But then, so that leaves me with 2x plus another 2x, so plus 4x. Minus 4 all over x plus 2 squared. All right, so I look, there's no way that I can factor the top so that I multiply to a negative 4 and add up to a positive 4. That's not going to happen because of that negative 4. And I just want to double check that is a negative 4. All right, that's all we got. So that derivative is done. Okay, that one wasn't too bad. This next one actually is going to be even easier. And then we get to D. D is crazy. All right, so here we go. Letter C. All right. The derivative of the first, let me just maybe make a little division here. Okay, so now I'm going to move over. All right, the derivative of the first, 2x times the second, x, minus the derivative of the second, which is 1, times the first, all over the bottom one squared. Okay, so let's see what we get here. I'm going to try to write tiny. 2x squared minus x squared minus 1 all over x squared, which will simplify into x squared minus 1 over x squared. Nothing you can do there. I mean, you could do x minus 1, x plus 1 up top, but that's not going to simplify, so I'll just leave it. All right, this is where it gets crazy, letter D. And like I said, I'm going to write it out, and I'm going to write out the actual final answer, and I'm going to write all the steps in between, separate sheet of paper. I actually have it done because I redid it. There's a couple different approaches, but I'm going to keep it simple for now, or at least try to. All right, so here we go. Let's see. Let's do pink. All right, derivative of the first, which is, let's see, 4x cubed plus, looks like 8x, derivative of the first times the second, minus the derivative of the second, which is going to be 6x to the second, times the first. So x to the fourth plus 4x squared minus 4. Is that all in there? And that's going to be over the bottom 1 squared. All right, so your final answer, okay, and I want you to try it and definitely check my key. Algebra is key here, and I think I said it before when I was talking to my boss about the AP Calc course. He said it's just a really high-level algebra course, and right here, he's right. I believe him. All right, so the final answer, let's see what we have here. You're going to wind up with x times x to the 5th minus 4x cubed minus 8x squared minus 12x minus 16, right? That's your top, all over 2 times x cubed minus 2 squared. All right, that's what the final answer turns out to be in purple. I'm not going to torture your souls, like I say, but you should do this one on the separate sheet of paper, because I do want you to try to simplify this, because it does get a little crazy. And then you could double check what my answer came. Make sure you're doing the algebra right. Anyway, moving on, derivatives of the trig functions. All right, we did the first 4 the other day. We're actually going to investigate tan x, but I'm going to do it on the second sheet of paper, and then we can go back and fill it in, just so you have a nice little chart. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine, and the derivative of negative cosine is sine. Remember, I told you guys this was the beginning of my downfall, where I struggled because I didn't memorize these. We'll get back to the tan one. We'll go back to it and we'll fill it in. All right? All right. I have to tell you, D was probably the toughest problem. So, you know, no worries. If you get through it, you're all good. The rest of these should be fairly easy. All right. So, derivative of tan x. Okay? Again, I want you to think of the quotient rule. So we're going back. If you guys remember, tan is sine over cos. And now we're able to figure out what the derivative of tan is using the quotient rule. This is kind of cool because it kind of proves it, so you know where it comes from. All right, so we're going to do, again, derivative of the first times the second minus the derivative of the second times the first, all over the bottom squared. All right, so here's how it goes. Ready? Derivative of the first, derivative of sine is cosine, times the second guy, which is cosine, minus the derivative of the second. All right, derivative of cos is negative sine times that first. And that's all over the bottom one squared, cos x squared. All right, so here's what you get. You get cos squared x plus sine squared x all over cos squared x. Remember from the past when you have cos times cos, it's cos squared x, right? Because you're squaring the function, not the angle. All right, anyway, you guys should recognize, right? Cos squared plus sine squared is 1. 1 over cos squared x, but 1 over cos is better known as secant. Secant squared, because it's cos squared. 1 over cos squared is secant squared x, and that is your derivative of tan. So go back to the page prior where you see tan x, right? We have secant squared x. So the derivative of tan x is secant squared x. Okay? We just proved it. All right, so now we are going to let's see, we're gonna do this next one. All right, so I want you to set it up. All right, now come back to you. Remember, cotan is cos on top, cos x over sine x. So take a sec, figure out if you can simplify that, and then we'll go back and see what it gives us. All right, let's see. All right, you ready? All right, derivative of the first times the second. So derivative of the first, so derivative of cos is negative sine times your second, minus the derivative of the second is just cos, times cos, all over the bottom one squared. All right, so I got a negative sine squared x minus cos squared x all over sine squared x. All right, so this kind of is like this guy here, but remember we need a cos squared plus sine squared? Well, we can get that if we just factor out a negative. So negative sine squared x plus cos squared x all over sine squared x. All right, that's going to give you a negative, this is a 1, over sine squared x, which is going to give us negative, and sine squared on the bottom, 1 over sine is cosecant, so negative cosecant squared x. That's the derivative of cotan, and that's where it comes from. Cool beans. All right, so let's do some more. These aren't too bad. Let's just take a look quick, right? Hopefully they're not too bad. Ooh, I hope you guys all saw that. All right, so back to letter C. All right, so we have derivative of the first, which is a 3, times the second, minus the derivative of the second, ooh, this one's easy, times the first, all over the bottom one squared. Okay, so this is going to give me 6x plus 3 minus 6x plus 4 all over, oh, this is like a breeze, 2x plus 1 squared. Let's see, 6x's cancel. It looks like I just got a 7 on top, and then 2x plus 1 quantity squared on the bottom. Easy peasy lemon squeezy. All right, I'm hoping this next one is just as easy, maybe a little bit more involved because, let's see what happens. Derivative of the first times the second minus the derivative of the second. All right, that's 4x times the first all over, ew, the bottom one squared. That could be messy, but let's see what happens. All right, let me switch my colors. 2x squared plus 5 minus 4x squared. That's not too bad. All over 2x squared plus 5 quantity squared. What's that going to leave me with? The only thing that simplifies, let's see, 2x squared negative 4x squared. That's going to leave me with, let me go purple, negative 2x squared plus 5 all over, oh, I thought this would be a little bit more eventful. 2x squared plus 5 squared. Can't really do anything here. If this was a minus, then it would have worked out a little bit better. But it's not. So that's your final answer in purple. All right, the last question really isn't obviously not a quotient. If you guys recognize, I think I just threw this in here for giggles here. You have the definition of the derivative. And they want to know what the actual derivative is. So if you wanted to, you could algebraically clean up E, but nobody wants to do that because I have x plus h to the fourth, so that kind of stinks. But if you remember the definition of the derivative, right, you are subtracting, right, f of x. So if I look here, right, let me see, make sure you're in the screen here. I have this second piece, right? Minus 3x to the fourth plus 4x squared minus x. Now remember, that's minus my f of x, so they've already distributed it in the negative. So what you can do here, this is kind of a neat problem. Take out the negative, leaves you with 3x to the fourth, let's see, minus 4x squared plus x. All right, so this guy here is your function. And they want to know what the derivative is. So actually just what I boxed in, just figure out the derivative using your power rule, right? Drop the 4 in front, we get 12x cubed. Drop the 2 in front, minus 8x plus 1. And that, loves, is your derivative. And where can we find that? Oh, in this funky, I guess I cut and pasted. Choice BC. For BC Calc. Maybe that's what I was thinking. All right, so that's a scoop. So remember, check the algebra that I'm going to post on the answer key, right? So with Thornton's notes, I'll put the worked out answer for D, example 1D. All right, enjoy your day, guys.